So we have to talk about where this laser business comes from. I told you I can't give a lecture about lasers and not mention some of this. So this is a really, he's a great looking guy. I mean, he's a stud. But it's okay because I guess the brains make up for the looks. So Albert Einstein thought about physics in 1917, thought about light in 1917. And he developed the concept of light traveling in waves of particles, which became known as light amplification by the stimulated emission of radiation, the acronym being laser. Now, I came across this fellow, looks like a nice gentleman, Dr. Leon Goldman, and the reason I put him in the lecture is that actually in 1961, he did research on the use of the laser in medical practice. So in medical practice, it's been almost 50 years. What are we waiting for? I mean, if you can treat a brain tumor with a laser, I think you can treat calculus with a laser. Of course, I'm pressing the point, and it still has to work, but you get the idea. I mean, how many 15-minute increments on the radio have to go by before you hear an advertisement for LASIK? Well, it's the same thing. It's a different machine, but it's the same concept. So I think the dentistry is ready to break out of this cocoon and maybe shift into a different thought process.
Why does it take dentistry so long to do?
You know what? It's a great question. I'll answer it when I'm done.
Okay.
Okay. This gentleman is in this line now, Einstein, Goldman, and this guy's name is Robert Gregg. He is a general dentist in California. He founded the company Millennium Dental Technologies. He partnered with another general dentist who also had a degree in engineering, and they actually came up with the concept of what we're talking about. The video I showed ahead of time, they came up with that whole thing. So this gentleman basically 12 years ago started using this machine in his private practice, and it's a general dentist office that actually started this revolution into what we're talking about tonight. So I want to acknowledge him, as he's very important, and he's the CEO of the company, and he teaches the CE for the company that I go to. Okay. I'm not going to spend much time because this gets into physics, and we don't, look, it's Thursday, we worked, it's the end of the week, you got wine in front of you, but this is the electromagnetic spectrum. What we're talking about really is every laser is a different color. You can see it maybe, or you can't see it. The laser we're talking about is it's called the near infrared zone. So that's all I'm going to say about this. But we're not going to talk about electromagnetic radiation. We're just going to talk about the fact that there are different colors of lasers, different colors of light, and every color of light has a different property. That's all you need to note. It's the property of this particular laser is what makes it work. The only other thing to know is this is an electromagnetic wave. It looks like a sine wave. We all took trigonometry in high school. This is a sine wave. You see the crest and you see the trough. The laser works by shooting light at different wavelengths. So you have long wavelengths and short wavelengths. If it's a short wavelength, it gets rid of more tissue. If it's a long wavelength, it gets rid of less tissue. That's really all we need to know about this. But this is what it is. This is about light going in wave patterns. And these are the properties. We have refraction. So let's say that I pointed a laser at that wall. Refraction is if it goes through that wall and still does some damage, that's a pretty powerful laser. So that's one element. Reflection is I point a laser at that wall and it comes back and hits me. That's reflection. Sunlight is that it just hits the floor and goes everywhere. So when you're out in the sun, sunlight is just called scattered light. It's not focused at all. Absorption is the most important property because it's absorption that causes in the mouth what will happen when you point the laser. It's the absorption into the specific tissues of the mouth is where you get the action from the laser. So if you remember nothing else about the physics of a laser, just remember it has to do with absorption and it has to do with a particular wavelength. That's all I want you to know. This is a schematic of a laser. It's quite simple. The laser that we use is called an ND-YAG laser. This is it's a crystal, it's an element. ND is neodymium, yttrium, aluminum, garnet. All put together in a block, in a crystal, and it gives off electrons. And then there's a power supply and a flash lamp, and all this action happens inside this chamber, and you get a laser, and it looks something like this. So I don't want to belabor the point, but it has to do with the neodymium crystals getting excited and releasing electrons, and the electrons releasing photons, and the photons being focused and becoming a laser beam. And that's all I think we need to say about that. Does anyone have a question about laser physics? If you have a question, that means you're... Is there any question about that? I don't know if I can even answer it, but okay, good. Thanks for letting me off the hook on that one. This just shows us what I said, that dental lasers are all a specific wavelength. And there are lots of lasers. Some of them are good for dentistry and some are not. I'm not here to speak about any other laser except the one in my office, but there are other lasers. Maybe some of you work in offices where there are other lasers. I guess the one thing I would say, the only thing I would say about it is that what I'm speaking about tonight and the properties of what I'm talking about tonight cannot be accomplished with any other laser except the laser I'm speaking of.